Okay, so we're trying to solve. Let me bring this over where you can see it a little bit better. J equals, put a bar here, and K plus 2 over M minus 7. Notice we have lots of letters. That's what we're doing now, solving these things that have lots of, let's put the equal sign as our wall of separation. We have lots of letters. Okay, so how do we handle when you get so many letters? Well, so first off, notice that we have fractions with an equal sign. We have fractions with an equal sign. Step number 1 is to multiply both sides. Well, let me say that more clearly and carefully. Multiply all the terms on both sides by the LCD over 1, right? And so common denominator over 1. So let's do that. So that's going to be M minus 7 over 1. That's the only denominator. M minus 7 over 1, right? Both sides. And then step 2, cancel denoms. That's the reason you're doing it. You want to get rid, we don't like fractions. Fractions are a pain. We want to cancel them out. So M minus 7 cancels over there. And we get K plus 2. What happens on the other side? Well, the 1's not doing anything. You don't even need the 1. The J is going to multiply through here. We're going to get MJ minus 7J. Let me write that a little bit better. MJ minus 7J. Does that make sense what happened? That J multiplied through. It cancels, and over here, the M minus 7 is canceled. How are we doing? Is that good? So I multiplied, whenever you have fractions, you got to multiply both sides by the LCD over 1, M minus 7 over 1, M minus 7, and then cancel denominators. And over here, it has to multiply. Okay, now what are we trying to do? Well, at this point, it's pretty much solve. Solve for what? Well, they could ask us for any of those. They can say get M alone or J alone or K alone. And this one, they're asking for M. So you got to kind of, focus in on which letter they want you to solve for. Solve for M. They want me to get M alone. So how do I get M alone? Well, here's the M right here. So M is saying, I want to be alone. Okay, so that means what? Get rid of this 7J and get rid of this J so that M can be alone. That's what it's going to take, right? To get M alone. Okay, and so let's do that. Let's get rid of the 7J. So that means I'm going to add 7J to both sides. And we good there? So I just added 7J. And it doesn't matter. You can put the 7J in the back or the middle or the front. It doesn't matter. There's just a bunch of terms added over here. It doesn't matter where you put things. Any place will be fine on them. Anywhere you want to go. So that's what we're looking at. Like that. Okay, so now let's keep going. We're trying to solve for M. So what do we do next? Well, let me check one thing to make sure I know how they're gonna do the answer. So our next step, actually 2 ways we could do it. Let's see. Yeah, they'll take it either way. Great. All right. Yeah. So the way we're going to do this then, we got to get M alone. So how do you finish getting M alone? Well, I'll write The last step is to divide. But whenever we do that, divide all the terms, left and right side, all the terms. So I'm going to go, I'm trying to get M alone, right? So divide by J, divide by J, divide by J, divide by J. Like that. Or I'll say, or one big bar dividing on both sides. That means the same thing. So you could just do one big bar divide by J, because you're still dividing them all. See how they're all three over that J? Either way, it means the same thing either way. You just have to divide everybody, right? Whenever you have an equal sign, we have to do equal treatment. All the terms on the left, all the terms on the right. There's two ways to do that. But one big bar with the J underneath, that's dividing all three of them. Or do three separate bars. Either way, it's fine. Now, these will cancel, right? And we'll get M equals, and then it's just 7J plus K plus 2 all over. Oops, better job on that. All over J. And that's our final answer. Now, couple key questions and observations. Can we cancel those J's? No. Let me see. Remember, you cannot cancel. This will be step 5. Cannot cancel added, subtracted items. We've seen that rule before, huh? Right? So this 7J is adding to the K. So you cannot cancel added, subtracted items. So you just stop right there. That's your final answer. But let me do the or option, because there is another option. I'll say or, right? I could have said M equals, and I could have put the 7. I could have divided them each. I just want to show you either option, because on the exam, it might be multiple choice and you want to recognize it, right? That's the other option. Instead of the one big bar with the J on the bottom, that's a fine answer. I just tested it. The computer system will take this answer. It's good. You cannot cancel those J's because you cannot cancel added, subtracted items. But the other option on the last step, right, is you could divide each of the terms individually. That's the same thing. One big bar with everybody on top of the J, or each one individually dividing the J. It's the same thing, right? The whole thing, all three divided by J, or all, all three as one big group divided by the J, or all three individually divided by the J. It's the same thing. It's valid either way. That's why I say or, right? Or you can do it the other way, or one big bar dividing both sides, which I did right there. And this one I'm doing right here. So anyway, what would that become? Well, that would these J's can cancel. You say, whoa, I thought you said, well, yeah, see, if I do that, that's 7 and J. There's no adding between them, right? You say, yeah, but there's adding here. Yeah, but that's a whole different fraction. That's a whole separate fraction. So it's okay to cancel these J's because this one is times. He's not added to anything in the top of the bar. So then that would become 7. Now the other ones just stay as they are. K over J plus 2 over J. That's also a totally valid answer. Let me put a box around that one also. So in other words, both versions are correct. And I just tested both versions. The system will take them. And you could see either one on a multiple choice test. I don't want you to be fooled, right? What if you're doing a problem like this and you end up with this answer because you divided all three individually by the J, and the multiple choice answer on the exam has it like this because they divided all three as a group by the J, and therefore we're not able to cancel the J's because there is adding in the top of that fraction. You can't cancel added items, so they just leave it like this. on the multiple choice. And you're looking at this going, oh, wait a minute. No, it's not the same. Yeah, it is the same. Make sure you grab that option. That's the same answer as yours. It's just a different version. So is that last step making sense? So on the very last step, when you're going to divide, remember, you have to divide all the terms, but there's two ways to do it. You can divide all the terms as one big group over the j, or you can divide all the terms individually over the j. And if you do that, you're allowed to cancel the j's because there's no adding on the top of that fraction. Whereas if you do it this way, you need to leave the j because there's adding in the top of that fraction. So either way is good on that one. There we go.